Hey everyone, Correct Genes here, and I have a quite unique lock for you today. And I will preface this video with a bit of a warning, or I guess disclaimer, that this is not a pick video. I will not be picking anything in this video. And due to the both complicated and rare nature of this lock, I will also not be gutting this lock. However, I will do the best that I can to both demonstrate and explain the different mechanisms inside of this lock using all the information I have about it. So this is the proof lock. And this is a lock for which there is, from what I can tell, almost no information available except for a single document that was filed in 1971 by an inventor named Sam Xiaoming Su, which details, well, everything about how the lock works. This patent exists. A company called Prooflock International presumably existed at one point, but no information about it is really available besides the fact that it is a name that was a company at one point. And beyond that, there is nothing about this lock anywhere else on the entire internet that I can find, which is absolutely incredible to me. And then even more so that somehow a random eBay seller in New York ended up with two of these locks for sale, one of which I sent to Supalama over in Canada, and the other of which is here with me now. So I have the pleasure of showing off this, what seems to be an even unfinished prototype of an extremely complex locking mechanism. So let's go ahead and get into everything that's going on here. Now, as you can see, there are three different types of key for the proof lock. The first is called the permanent access key, and it has a 5-pin pin tumbler component with a circular keyway that tensions from this little back piece, as well as a 7-pin tubular component which interfaces with the front of the lock. And as the name suggests, this key has permanent access to this lock. It is always able to open it, no matter which setting it is in. The second type of key is the limited access key, and this key only has the 5-pin pin tumbler portion, and as you might guess, is only sometimes able to access the lock. In this case, it is able to access the lock. However, in order to change that, you use what is called the control key. The control key switches the lock between what is called trapping and non-trapping mode. So it is currently in non-trapping mode. However, if I insert the control key in here and turn left, heard that little click, the lock is now in trapping mode. Now it is also important to note that the bitting on this key is different than the tubular bitting on this key. And there are actually only 5 pins on this one versus 7 on this. So now we are in trapping mode. The permanent access key still works, like so. However, when we put the limited access key in, as you might guess by trapping mode, turn it a little bit. Now that we've turned it a little bit, it actually cannot be turned back any further or removed. And then there's a little slight click, and now the key is trapped. The key cannot be rotated any further in either direction. Now this key can now be removed from the lock by once again using the control key, which is designed to fit over the shaft and can be inserted and rotated to the right to re-enter non-trapping mode. And now the key works again. So those are the basic mechanisms of the lock. It has two modes. It has a trapping mode, and it has a non-trapping mode, and it has a key that gets trapped in the trapping mode, and it has a key that works all the time. And then finally a key in order to switch between the modes. So next, I'll try to show you as best I can how that works. And thankfully, it is actually possible to view that mechanism from the outside, or at least the direct mechanism which traps the keys and prevents the core from moving when in trapping mode. So I'm going to go ahead and get this clamped up so that I can get a good view of that, and we'll do that. Alright, so we are now looking at the back of the lock, and I am going to operate the lock in its different modes from this view here. The things that you're going to want to watch are this trapping disc attached to this little cylinder here, running across this groove called the trapping pin. And at the base of this disc is a little finger down here. And that's what's going to be interacting and trapping the lock. The mechanism for trapping this finger is going to be behind the actuator here. This is called the trapping plug. It's these little teeth. And what I'm going to do right now is go ahead and operate the lock with the permanent access key. And you can see that underneath on that trapping plug are different little textures. So you can see that it's sort of pushing out here and then drops off right there, and then drops off again right here, and then rises at the other edge. So the lock is currently in non-trapping mode, so if I use the limited access key, the lock will just work fine. So what I'll do now is put the lock into trapping mode. I can align to it, it's facing away from me. There we go. So when I did that, you saw the trapping pin sort of push forward. It's under a spring bias, and a block has been removed that allowed it to push forward. And you can see that the little finger here is now resting up against this nub. So I'm going to operate the lock again using the permanent access key. And you can see it actually moves forward a little bit, but doesn't drop any further than that. It sort of stays at about the same level. And now I'm going to operate the lock with the limited access key. And as soon as I turn the plug just a little bit, you see the trapping pin drop down the first level. And now the lock cannot be moved back. It can still, the core can still turn a little bit. I can keep turning in the same direction, but I cannot get back to 12 o'clock and remove the key. So if I continue going, we will hit the second drop, like so, and you can see that the little finger on the trapping disc has now fallen into that groove, and the plug is completely trapped. So when I now take the control key and put it over the limited access key, and figure out what I'm doing back here. So I'm going to exit trapping mode now, and you can see that the trapping pin gets pulled back, and so that finger is no longer stuck inside of the groove, and the plug can continue to be rotated, like so. Now the limited access key works just fine because the trapping finger is no longer interfacing with those grooves. So that is the basics of how this lock works. This trapping finger here drops into these grooves when the limited access key is used in trapping mode and prevents the lock from turning. So at this point in the video, I hope I've been able to sort of show how the lock is working on a general basis, and after this point I'm going to go into a little bit more of the meat using some of the diagrams from the patents. Alright, so now that you've seen the mechanisms in action and seen the trapping mechanism trap the lock, let's go into a little bit how these things are working. For example, how is the control key moving the trapping pin around? Why does the permanent access key prevent the trapping pin from falling into the trap? Why does it fall into the trap with the limited access key in use? So as you can see here, we have a full diagram of sort of what's going on in the lock. We're going to kind of put that aside right now and start getting into a little bit more of the specifics. The first thing to talk about is the control key. So this is a schematic that shows a limited access key, but has a good view of the different shear lines that are used by the tubular portion of the lock. So the tubular portion of the lock, and you can see one of the tubular pins indicated here, has 4 shear lines. The first shear line here is the limited access shear line. This limited access shear line is is set to be the shear line that all the pins are sitting at when no tubular pins are pushed in. When they are at rest, this shear line is aligned and will always rotate. The second shear line here is the permanent access shear line, and we'll talk about that in a little bit. Then here we have the control shear line, and then finally we have a free spinning fake shear line, which does not do anything, it just spins and just keeps you from getting anywhere. So the control shear line here is aligned by these 5 pins, which of course means that for the 2 pins up at the corners here, both the limited access and control shear lines are at rest set. So when the control shear line is operated, what you saw is when trapping mode is exited, when trapping mode is entered, the trapping pin drops back like that, and when trapping mode is exited, the trapping pin recedes. So the trapping pin is under its own spring bias, and that can be seen back in the original diagram here with this large spring. When the control cam is actuated, this is the control cam, this is rotated. Now when it is rotated clockwise, an additional little finger at the on the side of the control pin nearest to the front of the lock, so it's sort of like right up in here behind the face, rides this track on the control cam, which sort of pushes it upwards, and when it reaches the non-trapping point, a little ball bearing under a strong spring tension is released into this groove, and there is also a little ledge that this piece gets held on while it is in non-trapping mode. And overall, it's mostly held in place by the little ball. The ledge is used in order to get it out of trapping mode. And so you have an opposite end of the cam, which has sort of an upper scoop, which is higher than the level that it is placed in when it is put into non-trapping mode. And all that does is it takes this little piece here and it sort of wedges it downwards, which puts enough force on it to overcome this ball bearing and spring back under its own spring tension. And so that's how the trapping pin is being actuated. Next is the permanent access key. So the permanent access key operates on this permanent access shear line. So the permanent access shear line is a bit difficult to talk about because there really isn't a good diagram in the patent that describes exactly what happens when the permanent access shear line is used. This is actually another good diagram for looking at the control shear line. Let's see if I can find... Okay, here we go. So this is the best diagram for looking at the permanent access shear line, and it's still not very good. So this is another little nub coming out of the control pin, which is on itself used for the permanent access. Now there is a disc right around here. You can't really see it because this is a profile, but this is the best they have, which when it is not rotated at all, has a notch in it that this can fall into and allows this pin to spring backwards and trap the lock. Now when the permanent access shear line is rotated along with the main plug, what happens is that notch is moved out of place, and so there is only a solid metal disc here, and that means that this little nub cannot recede. And when this cannot recede, this entire pin does not move. And that's all there is to it. So the permanent access shear line rotates a disc out of place, which prevents the pin from moving. So that about covers everything. You can see when you're turning not at the permanent access shear line, you're sort of just not turning this little shaded area here. This disc isn't turning and the key gets trapped. So the last thing I'll mention is this is not a complete prototype. There are actually diagrams for mechanisms inside of this patent which are not implemented into the lock. And specifically, it is a dial mechanism. So the patent describes a dial mechanism, which has 24 numbers on it, and when the correct number is selected, it allows the limited access key to be used without being trapped. Now, this functionality is not incorporated in this lock. However, it seems to have been in the works before something caused the project to be scrapped, and I honestly don't know what, because this lock came with this piece here. And this covers the lock like so. It's just sort of what you'd imagine to be a normal Mortise cover, and I had no idea what the purpose of these notches were until I read through the patent, because there are in fact 24 notches here, one of which has a deformation on it, which would presumably be used as the mechanism for overriding the limited access key. And actually I feel like if this were to be implemented, that would probably be the easiest way to defeat the lock, is trying to feel a way to override limited access by decoding what this number should be. Overall, this is a very impressive lock that has a function which evidently was not required. It is an extremely overcomplicated lock. You have a pin tumbler mechanism, which is designed to have additional components above it in order to operate with this dial. You have a tubular mechanism with 4 shear lines in it, as well as this entire plunger system here, in order to have these permanent access and limited access keys, the application for which is not entirely clear. And in the end, we all know it didn't work out. These locks, for better or worse, more or less just don't exist. This is a lock that is only known in patent, and for some reason has a prototype. So in the end, I'm just glad that I was able to get a hold of this, because this is a very cool piece of sort of lock history. The patent is referenced in a few other mechanisms used by a number of more well-known lock companies. So yeah, I hope you enjoyed, and have a nice day.